right now, that Falwell asshole has a video up, right, where he's going to measure the velocity of objects. So he launches them with a spring, and instead of measuring their velocity here, I mean, the whole thing is videoed. The only thing we don't see is exactly how far his little skittles go. So he's just going to, it's just like the rolling argument, except he's sliding. So friction's going to take all of the energy. Friction's going to consume all the energy of the objects. So we can have the same expectation about mass. Reducing the mass is going to make the object move further because it's the same spring. So we know it's going to go at least faster, and the question is how much faster. But all of these arguments, so what does he do? Instead of taking the velocities here, right, when they launch, because that's when they haven't lost much energy to friction, what's he do? He takes the velocities here. When you know that the one mass versus the half mass, there's every probability that the half mass is going to be going 4 times the distance. So we know this is going to lose its energy here. It's going to lose it much sooner than this object because the friction is so much less for the half mass object. And so they can't ever do anything. Why would you do this? Why would you check the velocity here when you know? I mean, obviously you didn't check it when the thing had already stopped, but I just mean it's such a cheat.
Well, talking of cheats, it was quite interesting in your little rant and rave and analysis there. But you concentrated on a 1 mass and a half mass. But you cheated the argument, didn't you? Because in the experiment, there was 3 launches. There was a 1 mass, a half mass, and a quarter mass. So we can talk about cheats all day, but you're cheating the argument here, aren't we? Let's be clear here. I put up an experiment, a physical experiment that showed results. You didn't like those results. I didn't mention you, make it personal in any way. I was just uploading physical evidence. You've obviously watched it, you don't like it because it doesn't agree with you. It doesn't agree with you because you're wrong. It's that simple. But like I say, I never mentioned you. I'm just putting an experiment up and showing physical evidence because that's what's needed. That's what counts. That's proof. Now, I seem to have some issue about where it was measured. That was clearly explained because as it's launched, the slow-mo has to kick in. So there's no point measuring it right here because the slow-mo, the frame rate, isn't the same. I measured it at point to point where the slow-mo was kicking in on all 3 passes, and the distance was the same, which is a fair comparison. Now, despite that, it's interesting to note that the results came out exactly as conventional science would say, or pretty much exactly. So, while you got this dispute about the distance being so far away, which actually isn't, if you can look at measurements on a ruler, it really isn't that far away, is it? We're not like 3 miles away. We're at like an inch or 2 away. But there you go. So it was simply because obviously we wanted the frame rate for all 3 and the distance for all 3. So it was a fair comparison. And as I said, the results came out in line with conventional science. You seem to be bemused at how they measure energy in springs like it's impossible to do. Well, there's even a formula for that. It's simple. You've got a spring, it has a spring constant, and that's denoted by K. So when you know the spring constant, and then you've got X, which is the compression or the distance of compression, you can calculate the energy by taking half of K, timesing it by the distance squared, and that gives you the energy in the spring. It's not magical. It's very measurable and predictable. It's that simple. You seem to struggle with it because you don't understand it. Now, the measurement of being some distance away that seems to be an issue. According to you and your model, why should it be an issue? Because in a way, if you actually look at what you claim and what you say, I actually biased the 1 mass, because you're saying when we launch this, there's more energy going into this than there is when it goes to a half mass or a quarter mass. So by putting it some distance away, the one mass would have been biased. So it actually was in your favour, but it didn't come out in your way, did it? It come out conventional way. But your model, well, I say model, whatever bullshit you come up with, you're all over the place. Because in regards to this, so when we half it or we quarter it, it's lighter and it's going faster. So again, what's the big issue with the distance where it's measured? Because according to you, when we got the quarter mass going twice as fast, while you're saying it's got less energy from the spring, it is almost going twice as fast, and it is quarter the mass. So therefore, by your theory, it's got a lot less friction, hasn't it? Because it's going much faster, it's much lighter, it's going through the gravity quicker, it's producing less weight on the surface, and therefore it should shoot along. It should go a lot faster than predicted, but it doesn't, does it? And same with the half mass. That's going faster, that's lighter. So again, being this distance away shouldn't be an issue, because again, it's incurring a lot less friction as it slides across the surface. So again, what's your contention here? The problem is you've got excuses for one thing when it suits you, and then you've got excuses for another thing when it suits you. But at the end of the day, they were all launched with the same amount of energy, pretty much. Obviously, I did show the launcher on as we went down on the masses. Obviously it was shooting above the centre of mass, and that was a tiny little discrepancy. But all in all, the experiment does prove you wrong. It comes out almost exactly as conventional science would predict. It doesn't come out anywhere near your model, because your model doesn't work. It's just, like I say, you're so contradictory, you're all over the place, you've got excuses coming out of your frickin' ears wherever you want. When it suits you that it's going faster because it's got no friction, that's fine. But in this instance, when it shows you to be wrong, now it suddenly isn't getting all the energy and it's unfair. You're all over the shop. Like I say, at the end of the day, I never made it personal. I never mentioned you. I'm just uploading an experiment, a physical experiment, showing evidence, showing proof, and it doesn't match your nonsense. And that's ultimately where you get all upset and take it personally. I say, I didn't make it personal, you did. And also, with all of a sudden, with this launching the measurement here, you seem to be also concerned with the distance, how far it travels. Why such concern over that when you argue mass times velocity all the time? You seem to be concerned so much with the velocity, which is what was measured, and then all of a sudden, oh no, how far did it go? What was the distance? Well, again, I've shown that in the past. You didn't accept that either. So this is what you do. You just, every time you see evidence that proves you wrong, you just change the goalposts. You just say, oh, I want to see how far it went now. Or, like I say, the concern is the mass and the velocity. That's what you're always concerned about. That's what was shown. But then that's not good enough. Now it's the distance. You've seen that anyway. I've shown you friction, again, yes, they're under friction forces, and friction is linear. I've shown that in the past. So again, this distance measurement here, at some distance away, doesn't really matter because the friction's linear. Again, you didn't accept that either. Basically, you just don't accept anything that doesn't confirm your bias for your... like I say, I can't really call it a model. It's just your nonsense ideas in your head that you seem to think's right, that you show no evidence for. All the evidence that's shown to you confirms conventional science. You show no evidence, you just shout and scream like a 2-year-old and say, I'm right. Prove it. Prove you're right. Just show us one experiment where you're right. Because you don't do experiments. And to say they're not clinical, again, I can put a white coat on. What difference would it make to the results? You know, you can harp on saying, oh, they're not done clinically. Well, you know, they pretty much are. And they all prove you wrong, don't they? And that's the problem. That's the bit you don't like. They prove you wrong. Because, spoiler alert, you are wrong. It's that simple. You just don't accept it. It should be stark and clear here in anybody's mind that all the three masses were launched with the same energy. Yet we got different momentums, because you can clearly see that the energy is the same, but the momentums are different. So what does that tell us? The energy, this is the same, these are not the same. So energy isn't momentum. It's not the same thing. You know, it's quite clear. You just don't accept that, and you don't understand it.